And welcome back. And this is the session number 2 of the second day. In total, we are on session number 9 now, starting from yesterday. And we have an expert with us. And before I'm going to introduce you to Dr. Kwangil Lee, I'm going to tell you that when I was reading his profile, it was a never-ending profile, and he's the chair of so many associations around the world, an expert on smart ships. So we have a lot of students and a lot of seafarers and maritime professionals hearing us and watching us live on our Naval Connection YouTube and Facebook channels right now. This is going to be a very informative and learning experience for all of us, because Dr. Lee is an expert in smart ships. There were speakers yesterday. A few speakers spoke of autonomous ships, and one of the differences which I asked, and one of the questions which I asked them, was the difference between smart ships and autonomous ships. And today I will post those questions afterwards, after we hear Dr. Kwangil Lee. So let us have an introduction, a very short introduction of Dr. Kwangil Lee before I invite him to speak to us. So tech team, can you play the introduction of Dr. Kwangil Lee, please? He's from South Africa, but he's from South Korea, but he's presently in United States of America, Atlanta. Can we have his introduction, please?
Dr. Kwangil Lee. Kwangil Lee received a BS, MS and a PhD from the Department of Computer Science at Chennai National University in 1993, 1996 and 2001 respectively. From the year 2000 to 2002, he worked as a guest researcher at National Institute of Standards and Technology, NIST, USA. Then he worked as a research associate at the University of Maryland from 2002 to 2004 and University of Texas 2005, USA. From 2006 to 2017, he had been a principal researcher at IT Convergence Security Team at Electronics and Telecommunication Research Institute, Korea. Since 2017, he became an assistant professor and a head of International Maritime Technology Standard Center in Korea Maritime and Ocean University. He is the secretary of Korea Autonomous and Unmanned Ship Forum and a member of International Network of Autonomous Ship, INAS. He is also one of the active participants in many maritime international standardization works such as IMO, IALA, ENAV, IEC, and ISO. Presently, he works as a convener of IEC TC80 WG17 Common Maritime Data Structure Working Group since 2015. His research interest is on the autonomous ship, smart ship, e-navigation, common maritime data structure, cybersecurity, and safety, ship area networks, mobile wireless networks. The Naval Connection proudly presents Dr. Kwangil Lee as a speaker at the Technology in Maritime TIM 2021 Global Virtual Conference.
Dr. Kwangil Lee, we are so proud to have you, and I'm sure it's such an exciting thing that we as former seafarers and also maritime professionals will be looking forward to hearing from you about the smart ships. So you're speaking on smart ships. I suppose you have, speaking from experience and speaking for the research and immense technical knowledge that you have. We invite you on stage to share your experiences and share your views with the global audience at TIM 2021. Dr. Kwangil Lee.
Okay, thanks for the introduction. And then it is my great honor to present to participating in TIM. Today, I'm going to introduce the title of my talk will be the maritime connectivity for smart and autonomous ship. So basically, what kinds of technology might be necessary to realize the smart and autonomous city? That will be a topic of my talk today. So I will introduce some background and what is smart ship and smart shipping, and then data connectivity, and I will conclude my talk. So many people are thinking about talking about the Industry 4.0. So that might be an impact on the maritime industry. So right now, the maritime industry is moving to the shipping 4.0. So many technology is introduced in the maritime industry. When shipping 4.0 will bring what kinds of changes in the maritime industry? I'm going to say that is we need to realize the seamless maritime connectivity. This means shipping, every shipping shall be connected together, and then all maritime service shall be automated and streamlined without any human interruption. So all systems and devices shall be operated and monitored by digitalization. And then this means device and system shall be integrated and interoperated. So how this maritime society, maritime information can be connected to the other shipping or logistics information. So all from the beginning and from the customer to the customers, every information shall be exchanged automatically, and then all the systems shall be automated. So what kinds of things might be necessary to realize those kind of things? So I'm going to say the components for seamless maritime connectivity, that could be autonomous ship and the smart port, and then smart equipment and system, and then communication infrastructure might be necessary. And then these systems need to be interoperated and then harmonized with the various stakeholders. The most important factor to realize those kind of things is, I say, data and communication connectivity, and the system interoperability might be an essential factor to realize seamless maritime connectivity. To realize the seamless maritime connectivity, we need to resolve several issues. What issue? The main issue is how information can be exchanged among various stakeholders in different domains. As you might know, in the ship side, navigation, engine, cargo, safety, people, crew, and then operated in separate systems. On the shore side, shipbuilder, ship owner, authority, and service provider and service consumer. Also, they have their own data and their own system to achieve their own goal. However, to realize maritime connectivity, the ship and shore side need to exchange a lot of information, such as ship reporting, ship safety information, operation, and then traffic control, and the others, additional service. How those data can be, exchanged with common understanding, and then automatically, that kind of things, to exchange those information automatically, then we need to define, we need to have a common way to exchange those kind of data, and then common way to interpret those kind of data. That could be a very essential thing. However, as you might saw, what's the scope? There is too much stakeholders. So this is the common stakeholders. So how to harmonize all the data, including onboard the data, and then on the shore side, ship side and shore side, how those data can be exchanged. So one simple solution in my thinking is a single window. Single window is defined as a facility that allows parties involved in trade and transport to write standardized information and documents with a single entry point. So a single entry point can collect all the data, and then based on those data, each stakeholder make its own decision and then get each information. So in the maritime world, this single window is also promoted by the UNECE and the WCO and then ASEAN. The maritime single window is defined as software that will perform many different tasks within the realm of ship reporting and information exchange. So basically, in ship reporting perspective, maritime single window is promoted by the IMO. So IMO maritime single window is defined by the FAL, and then they are going to provide an automated ship reporting. This is one of the way to achieve the harmonized data. This to support to the maritime single window, ISO 2805 series is proposed. This is to provide safety and security information requirement between ship and port and the coastal side authority. So this is mainly proposed for the electronic port clearance. So this ISO 2805 series provide define the data element and then how those data can be defined. This standard is provided to support EPC. Recently, IMO FAL agreed to extend IMO compendium on facilitation and electric
Dr. Lee?
So they are going to define data elements related to FAL convention as well
Dr.
as
Lee,
data sets beyond those mandated by FAL.
Dr. Lee, can you hear me? Yeah, I'm sorry to interrupt you, but we are getting a white screen.
Yes.
Yes, we got your screen right now. Yeah. No, we were just getting a blank screen, but now I have got your ISO 28005 now screen on. Yeah, so you can please continue.
Okay. Yeah, sorry. And then this, because each port has their own, ship reporting format. So IMO is going to have one of common standard data, standard ship reporting. So all the data elements is standardized, as you see in the screen. So all the data elements are assigned a unique IMO identifier. So all the ports and then all the ships, all the service provider might have a common data definition and the common data understanding. These kinds of work is going to do. Based on this file, data harmonization work, based on that, ISO is going to propose a new international standard, ISO 2805-3. This is data exchange for autonomous operation for ship and port. So data is classified nautical data and administrative data, operational data. So they are exchanging the one common operational data. Their port service and ship departure and arrival shall be synchronized. This might be reduce the waiting time, ship waiting time at the port. So this might be improve the efficiency and then CO2 reduction. We also need to think about the e-navigation, because e-navigation is also promote the harmonized monomean information by electronic means. So when the e-navigation is proposed by the IMO, IMO defines 16 service, maritime service. So as a result of the navigation, MSC provides the initial description of maritime service in the context of navigation. So they are providing how you can define the maritime service. So many different maritime service shall be defined in the common way, and then common provisioning might be possible. So first draft of the maritime service. This is a maritime service. So submitting body, coordinating body, this is operational approach and user needs, and which information, what kinds of information shall be provided for each service. So this is the IMO 16 advanced service, and then they are which submit organization might be responsible for the development, and then how each maritime service is interrelated with the other maritime service. Those kind of things are summarized in this table. Right now, we are need to discussing about the ship side, the maritime connectivity. They are going to collect all the information from the ship equipment and system. So one of the approaches is the ISO 19847. They are going to develop standards for ship data server. So ship data server collect all the data from the different equipment and system. This equipment and systems mainly focused on the engine and then cargo and like those kind of system. So this ship data server define the basic requirement how to collect those kinds of data. And then another approach is 19848 is how, because the engine has a lot of sensor data, and then each manufacturer has a different, their own identification information. So we need to have a common way to define those kind of data. So ISO 19848, they are defined how data element can be defined in different system and different equipment. So they are defined the code for each data element, and then they are going to harmonize those kind of things. So in the shore side, they are collecting all the sensor data from the engine or cargo, any equipment and system. So they are going to, based on this kind of information, Japan is developing their own smart ship platform. There is another approach in IHO. IHO is based on the S100. Actually, S100 is the next version of the S57. S57 is developed for the ENC requirements for IMO at this, and then there is some limitation on the S57. The IHO is providing S100. They are providing plug and play data, and then they are supporting a lot of symbology and then software enhancement. So they are not limited some specific data. So any data or any other formats can be interpreted and presented dynamically with their plug and play information. So right now, S100 is not limited to ENC. They are extended to the bathymetry and then weather data and the navigation warning. A lot of data is going to be developing under the S100 frame. So this is the list of the S100. So as you see, S100 is not limited to ENC bathymeter, and the weather overlay, and then a lot of data is providing with the S100. One of the S100 approach is S41. This one is a route plan based on S100. This is developing by IEC. So IEC is developed the RTZIP data format to support active route monitoring services. However, RTG is not for S100 based. So IEC developed the S100 route plan. So they, based on the route plan, schedule information and the waypoint lag information, and then a lot of action information. So some kinds of action need to be performed based on each waypoint. Those kind of information shall be modeled with in S41. Based on this S41, a lot of service can be provided. One of the services, route cross check. Route cross check is ship to shore is going to exchange the vessel's route is valid or not, and then is there any problems or not, or flow management. If there is traffic control might be necessary, then flow management shall be provided. In instant monitoring, so if a ship is going to navigate in the dangerous area, then British Center may send an alert to the vessel based on the route information. UKCM undertake clearance information also can be provided with the route plan. These kinds of various services can be exchanged with the digital format. So autonomous ship can be controlled and monitored by this kind of information. So my conclusion is seamless maritime connectivity is essential for shipping 4.0, so for the next generation of the maritime industry, because streamlined all maritime service from shore to ship. So we don't without human interruption. So all the maritime services shall be exchanged and then digitalized. For this, data and communication connectivity and system integration and interoperability might be provided. Most important thing is at this moment is the standard data for smart ship and smart shipping, which includes, because data connectivity is the scope is quite large. So, however, basically IMO file convention, because this is a ship shore automated reporting might be included. So IMO file convention might be definitely included. And then in navigation and application service, this one is already provided as a digitalized service. And then other onboard data, navigation engine, a lot of sensor, ship, vessel, system, and equipment information shall be exchanged uniquely. So those kind of information might be provided as a part of the maritime data connectivity. Maritime seamless connectivity contributes for the efficiency and reliability and environment for the maritime industry. If everything is digitalized and then seamless connectivity is provided in the maritime industry, then the shipping efficiency might be increased, and then CO2 reduction and the system reliability and the shipping reliability might be achieved. However, to maritime seamless connectivity is a long way to go. So we need to more efforts under a lot of work, especially data integrity and data quality, and then cybersecurity issues might be more focused to achieve Maritime fine general principle for common data platform because own data and their own systems. So to be connected together, we need to be discussing about what is the general principle and then how different data in different domains can be interpreted. So these kind of things need to be discussed. To achieve this, we need more participation and collaboration from the different stakeholders. So sometimes each domain has discussing their own issues, then real seamless data maritime connectivity cannot be achieved. So more stakeholders are participating these kinds of work, and then we need to have one we can really achieve the seamless maritime connectivity. That's all. This is my presentation.
Dr. Lee, yeah, you can please stop sharing now.
This is my presentation.
Yes, you can please stop sharing now, Dr. Lee. Yeah, thank you very much, Dr. Lee, for that immensely deep, what should I say? I can, I could almost feel so much of technicalities and experience coming through those presentations. Yes. Dr. Lee, I just wanted to ask you one question that was going, I saw and I heard you mention the concept of e-navigation. So, and the harmonization of navigation by electronic means. So can you just in very short, maybe in 1 minute, can you just elaborate on what you meant by harmonization of navigation by electronic means? Because presently we are already doing that on board ships, right? So is there any development on this and the e-navigation front?
All the information, is exchanging, but basically some of information exchanged with the voice, ship to shore, or they are exchanging or communicate with some voice information. However, e-navigation is going to provide to exchange all the marine information by digital electronic means. This means, digitized system, computer system or digitized with the electronic system, all the information shall be exchanged. And harmonized means, each service may have, if they have their own data, then it can be harmonized. Those data cannot be interpreted or cannot be understood. So harmonized means all the data shall be exchanged with a standard data format or standardized way. So for the navigation, as I mentioned, the basic template for the maritime service is defined, and then IEC is to define a common way to present all the navigation symbol and then layout of the navigation system, such as ACTIS. So those kind of things are achieved, and then for the autonomous ship, we need to extend more to the more system and more services.
Okay, thank you, Dr. Lee. And I don't want to let you go because but unfortunately we have back-to-back schedules. There is one last question which I want to ask you, and which has come in the platform. Somebody by the name of Roshan has put this question, and I put this to you. He asks, and very pertinent question, very interesting question: how safe are these data during the times of cyber threats? So he means to say, how safe is this data during cyber threat? Is this a cyber threat issue? Prevailing cybersecurity measures, anything specific has to be done?
Yeah, actually, the IMO defines interim guideline for the cyber risk, And then IEC also defines some technical requirement for the navigation system. So navigation network and navigation system is already defined. We don't know yet, vessel, for the vessel perspective, those kind of standard already defined, and then, but to achieve the seamless maritime connectivity port side and the ship-to-shore communication or all other cyber threats shall be analyzed, which part is a weak point. So those kind of things might be more studied and then researched, I think, more developed. But however, as I mentioned, at the navigation, the vessel side, those kind of standards already defined.
Fantastic. Thank you for this thought-provoking session, Dr. Kwangil Lee. You're joining us from America, from the distant corner of America, though you're from South Korea. But thank you for your engagement and your precious speech. This will be replicated by us live again, recorded, sorry, in our magazine and the Souvenir Audiovisual Magazine. And thanks to everybody for their engagement. And we have somebody, we have already the next speaker coming in, but we will take a short break here, 10 minutes, and then we will come back to you live again. So till then, it's Namaskar from Team 2021. Dr. Lee, thank you so much. And we will see you next. If there is any further questions, I will get back to you on email. So thank you for your time and energy and engagement, Dr. Lee.
Okay, thanks so much.